Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 14.2, Problem 6. This is Section 14.2, Problem number 6. It says, every year the business department at BCC offers a seminar about how to open your own used car lot on Route 6 in Westport. They have learned from experience that if they charge $600 per person, they will sell 1,000 tickets for the seminar. One of the professors from the business department claims that for every $20 reduction in the price of a ticket to attend the seminar, they will sell an additional 100 tickets. Find the function that determines the revenue based on the number of $20 price reductions given on the original $600 ticket price. So, the revenue generated from this conference or seminar is determined by price per ticket times number of tickets sold. That's how you calculate the revenue. So what they had been doing is the price per ticket was $600 and the number of tickets sold was 1,000. And at that rate, 600 times 1,000 would be $600,000 of revenue. Now, based on the idea that for every $20 price reduction they give, they'll sell an extra 100 tickets, what would the revenue function be? So instead of 600 for the price per ticket, it will be 600 minus 20 times x, where x is the number of $20 price reductions. So one price reduction, $580. Two price reductions, $560, etc. And now that number of tickets sold, which started at 1,000 tickets, would be 1,000 plus 100x. For every reduction of $20, they're going to sell 100 more tickets. So one reduction of 20, they'll sell 1,100. Two reductions of 20, they'll sell 1,200. As they reduce the price, they sell more, and there's some perfect point where they'll make the most money. Eventually, if you make it too cheap, even though you'll sell a ton of them, overall you'll make less. So that is the revenue function. Let me write revenue over here next to it. And I can simplify it a little bit, clean it up. Right now it's in two sets of parentheses, so I can FOIL it out and combine my like terms. So to do a nice job, let's do that, especially because it'll be very useful for parts B and C that follow. So to FOIL it, I'm going to do 600 times 1,000. That's 600,000. And then 600 times 100x. So those are huge, huge numbers. Just concentrate on 6 times 1. That's super easy. That's 6. And then 1, 2, 3, 4 zeros. So 6 with 1, 2, 3, 4 zeros is 60,000. It's going to be 60,000x. So that takes care of the 600. Now negative 20x times 1,000 will be negative 20,000x. And 20 times 1,000 is 20,000. That's pretty easy. Don't forget the x. Don't forget that it's negative. And then negative 20x times positive 100x. Again, big numbers. Forget the zeros momentarily. Just minus 2 times 1 is minus 2. And then how many zeros? 1, 2, 3. Put them back. So it's minus 2,000. And x to the first times x to the first is going to be minus 2,000 x squared. So now I've cleared my parentheses by doing the FOIL, and I do have some like terms that I can combine. I have two pieces with just an x to the first power. So to finish off part A, my function that determines the revenue based on the number of $20 price reductions will be 600,000. That just comes right down from the top, so now that's done. So I have positive 60,000x, negative 20,000x. So they're both in terms of x to the first. Positive 60,000, negative 20,000 will be plus 40,000x. So that's done, that's done. And now the minus 2,000 x squared, there are no other x squareds, nothing left to combine it with. Don't forget about the negative though, minus 2,000 x squared. So now that's done. So for part A, the function that determines the revenue based on the number of $20 price reductions is 600,000 plus 40,000x minus 2,000x squared. So now to go on to part B, it says find the price that will produce the most revenue for BCC. So we're going to take this revenue function and maximize it. We'll take the derivative of the revenue function, set it equal to 0, solve for x. So when I do that, revenue prime, the derivative of the revenue function, equals the 600,000. Because it has no variable with it, no x, its derivative is 0. So it's just gone. The 40,000x will have a derivative of 40,000. And as we've seen before, what happens when you have an x to the first power, the derivative is whatever the number in front of the x is. In this case, this big 40,000 number. I'll put in my comma too. And the piece on the end, negative 2,000x squared, its derivative is negative 4,000 x to the first. And again, that comes from the exponent of 2 coming down times the number in front of negative 2,000. 2 times negative 2,000 is my negative 4,000. And you reduce the exponent by 1. That second power drops down to a first power. So now that's revenue prime. We took the derivative of the revenue function. Next, we'll set it equal to 0. So easy enough. We'll just do 40,000 minus 4,000x equals 0. And just take the answer we had above and put a equals 0 after it. Now to solve that for x, I can simply bring the minus 4,000x over to the right side of the equal sign. It'll become plus 4,000x. And I have 40,000 equals positive 4,000x. Again, when I go to the other side of the equal sign, it'll become positive. Divide out the 4,000. Divide by 4,000. Divide by 4,000. And now my 4,000s cancel on the right side. And the 3 zeros in the 4,000 in the denominator will eliminate 3 of the zeros in the 40,000 on the top. I have 40 over 4, which I can reduce to 10. So I have 10 equals x. Now again, x is the number of $20 reductions in price. So if you started at a price of $600 and gave 10 discounts of 20 each, you're going to take $200 off the price, right? 20 times 10 is 200. So that $600 price is going to drop down to $400, and then but you're going to sell a lot more tickets. So the answer to part B is the price that's going to make the most revenue overall is $400 a ticket. So now part C, what is the maximum revenue? So when you do price times number of tickets, the price is $400 times the number of tickets. Well, if you're starting at 1,000 tickets sold and you're giving 10 price reductions, and every price reduction is going to sell 100 more tickets for you, 10 times 100 is 1,000. So you're going to go from 1,000, you're going to add another 1,000 people who will be willing to buy a ticket. So 1,000 plus another 1,000 is 2,000. So now $400 per ticket times 2,000 tickets sold. Again, that's a big multiplication. Ignore the zeros briefly, or just do it on a calculator, which is just as good. 4 times 2 is 8. How many zeros did we ignore? 1, 2, 3, 4, 5. So you put in 1, 2, 3, 4, 5 zeros. That's a revenue of $800,000. So that's pretty good. Instead of making $600,000, you can make $800,000. That's the most you can make.